So the exercise is related to the intermolecular forces. Yesterday we discussed the intermolecular forces, the forces between the molecules. It can be a dipole force, or it can be a dipole-induced dipole, or a hydrogen bond in a covalent molecules. And then we discussed the solubility of a substance like dissolve like. If we have ionic compound, then we check the hydration and the lattice energy. But if we have a covalent compound, we check a common type of force. If a common type of force exists between them, it means the substance will dissolve. So first 22 questions are already recorded. So I will start with 23. Look, remember the force of the boiling points depends on the type of the intermolecular force and the strength. Like for example, dipole-induced dipole force, it increases as the number of electron increase, or the surface area increase, it increases as well. So we have to work out first that identify the type of intermolecular forces. First 22 are already recorded, so we'll do 23. The strongest intermolecular force in liquid ammonia are covalent bonds are not intermolecular force. Remember, intermolecular forces can be dipole-dipole, dipole-induced dipole, or a hydrogen bond. These are the three intermolecular force. Covalent bond is not an intermolecular force. So, which force exists in ammonia? Remember one thing: when hydrogen is bonded to most electronegative elements such as nitrogen, oxygen, or a fluorine, it will form a hydrogen bond. So which kind of force is the existing? So that is a hydrogen bond. In question 24, the graph below shows the boiling temperature of group 5 hydrides. So we have to work out the position of ammonia. So if I write the compounds, we have ammonia and NH3 is there. Then there will be a phosphorus hydride is there, arsenic hydride is there. These are the hydrides of group 5. So what kind of forces are existing? Um, hydrogen bond is there. The major force, this is will have dipole force, and major force is dipole induced. There are other, but dipole induced dipole. But as you can see here, uh, from hydrogen bond to dipole force, the boiling point will decrease. But here dipole force to dipole induced dipole force, the boiling point increase. Why the boiling point increases? Because there are more electrons, greater number of electrons. That's why the boiling point. So ammonia should have high boiling point compared to phosphorus hydride. So it cannot be C or D because that shows low. So either A can be an answer or B can be an answer. But which one is likely to be an answer? The correct answer should be A. Why? Because the hydrogen bond is stronger force, so it will cause a greater difference in the boiling point as compared to. So if we select B, why B is inaccurate? Because B shows a small difference, small changes there. But the strength of a hydrogen bond is greater as compared to dipole-dipole force. As a result, the difference in the boiling point will be higher. So that's why A is the right answer. In question 25, which of the following compounds has the highest boiling point? Look, their relative molecular masses are given, as you can see. So if relative molecular masses are given, then what you will check? You will check the type of the force. Cyclopentane, like cyclic compound. So this will be CH2, CH2. There are no dipoles. There is no hydrogen bond because hydrogen is not bonded with fluorine, nitrogen, or oxygen. So what kind of force is existing between in the cyclopentane? The force which exists in a cyclopentane, that is dipole induced dipole force. Pentane also, if we have 5 carbon in a straight chain, and this will have 3 hydrogen, this will have 2 hydrogen, 2 hydrogen, 2 hydrogen, and 3 hydrogen. So there is a straight chain. This will have dipole induced dipole force because there is no like greater difference in the electronegativity of the two elements. Plus, it's a straight chain. Then butane 1-all. So but means 4 carbon, and alcohol is attached with the first one. So what kind of forces are existing? It will have dipole induced dipole force because of carbon chain, and because hydrogen is bonded with oxygen. So when hydrogen is bonded with oxygen, then it will have a hydrogen bond, and oxygen is bonded with carbon, so it will have dipole dipole. So all three type of forces are there. But ethane 1,2-diol means two alcohols are there. Ethane 1,2-diol means like two OH groups are attached. So there will be hydrogen bond here, there will be a hydrogen bond, there will be a dipole dipole here, dipole dipole, and then dipole induced dipole. So there are greater attraction in ethane 1,2-diol because of two hydrogen bonds, where butane 1-all is having only one hydrogen bond. That's why D will be the right answer. Is it clear? This one? So as the number of the bonds, like hydrogen bonds, increase, the boiling point will also increase. Then which of these molecules is a polar? So to be a polar bond, bonds are polar, and the geometry, the structure of the molecule does not cancel out. When we draw the structure of a carbon dioxide, it has a linear structure. Carbon is partial positive and oxygen is partial negative. But the two oxygen, they cancel out the effect of each other. They apply the same force, so they cancel out. So this will, A will be a non-polar. When we talk about ammonia, NH3, so as a result, what will happen? Because it will have a trigonal pyramidal structure is there because of the presence of a one lone pair. So these bonds does not have the same length. So one of the hydrogen bond, hydrogen will be nitrogen will be partial negative and hydrogen will be partial. So one of the bond will be polar, and rest all of and they are not able to cancel out each other. So the molecule will be polar. But in CCl4, carbon tetrachloride. So in carbon tetrachloride, all of them, they cancel out each other. So as a result, the molecule will be a non-polar. And CH4, the bonds are non-polar and the molecule will also be a non-polar. So B is the right answer because the geometry, as it has a bent like a trigonal planar pyramidal structure, as a result, all the hydrogens are not able to cancel out each other. Same case it happened for a water as well. Water is a polar compound. Why? Because of presence of the two lone pair, they bend. It has a bend structure. So one of the bond, even in water, what happened? Oxygen will be partial negative and hydrogen will be partial. That's why whenever water will dissociate, it will dissociate into OH minus and H plus. Because one of the hydrogen bond have a greater polarity than the other one. So when the bond break, it will be unequal. As a result, OH and H will it dissociate. Otherwise, if it was equal distribution was there, then how the oxygen the bond should break? Then both hydrogen should break the bond, and it produce two hydrogen ions and one oxide ion. But it does not happen like this. The water produce H and OH, which shows that the bonds of the water are polar and the molecule is also a polar. In question 27, which of the following compounds has a hydrogen bond? So I remember to check the hydrogen bond, what you have to check? You have to check hydrogen must be bonded with fluorine, hydrogen bonded with oxygen, hydrogen bonded with nitrogen. Only three elements hydrogen bond is possible. So here hydrogen is bonded with bromine, sulfur, silicon, and here we have bonded with nitrogen. So it will have a hydrogen bond. In a molecule of a hydrogen, the two hydrogen atoms are held together. So if we have a molecule of hydrogen, like this is one molecule of a hydrogen and there's another molecule of a hydrogen. So what kind of force is there between the two hydrogen molecules? So this will be a non-polar and this is also a non-polar. Two non-polar molecules are there. So when because the bonds are even, so there is no polarity. So when two non-polar molecules are there, what kind of force exists between them? That is a dipole, induced dipole force, also known as the London forces. So D will be the right answer. Because hydrogen bond exists when hydrogen is bonded with fluorine, oxygen, or nitrogen. Polar covalent bond, it's not an intermolecular force. Polar covalent bond exists within the molecule. It's a intramolecular force. And a non-polar covalent bond, that's again covalent bond. They have the non-covalent bond, but that is intra, not inter. But the question is, in a molecule of a hydrogen, so this is a force between the molecule, but they ask in a molecule of a hydrogen. So they ask for intramolecular. Sorry, I thought the question was about intermolecular, but it's a intramolecular. So within the between the molecule, it is dipole induced dipole. But between the, as I asked, in a molecule of a hydrogen, two hydrogen atoms. So two hydrogen atoms, how they are held together? They are held together by a non-polar covalent bond. So intramolecular is this intramolecular is a non-polar because the distribution, there's no distribution. It's evenly distributed, like there's no uneven distribution. It's evenly distributed. Between the molecule, if the same question was there between the molecule, then it will be London forces. At room temperature, iodine is solid and bromine is liquid. Best explanation. So we have a bromine Br2. So we have bromine, which is Br2, and we have iodine, which is I2. What kind of force is there? Because both bromine and iodine, they have like non-polar compounds are there. So for a non-polar compounds, the force will be London dispersion force. And this London dispersion force increases as a number of electron increase. So iodine has a stronger London forces or a dipole induced dipole force. And these dipole induced, because iodine is solid where bromine is liquid. Iodine is having a high melting point or a boiling point compared to that of bromine. And the main reason is because it's a non-polar covalent compound, and non-polar covalent compounds have the intermolecular force, which is known as the London dispersion force or the dipole induced dipole force. So this was an assignment related to intermolecular forces.